Thank you, thank you. Right, I was at a dinner party last week, which is actually a terribly middle-class introduction to a talk. I was at a dinner party last week, right? And we got onto the topic of what you're doing next week, and I said, I'm going to Copenhagen. They said, what are you doing in Copenhagen? I said, I'm going to give a talk at a conference. They said, what's the talk about? It's a non-technical dinner party. Have you ever been to those, right? And so, like, okay, so we have this thing in computing that lets us check whether our systems are correct, and that sounds like a good thing, right? But the talk is about how, as well as doing that, there's this whole other class of things that's useful it does, and people don't seem to realize that it can do that as well. And they kind of glazed over, right, as people do when you're talking technical at them, and I tried my best. But so I just want to say before we begin, thank you all for being the target audience for this talk. Thank you for giving me 40 minutes to explain what the heck I'm on about. And thank you all for being sober. That was another difference. Assuming you are still all sober. Maybe you're not. I don't know. It's been a 3-day conference. It's a Friday. Before we get started, I am talking about type systems. So, so my clicker has already broken because it's not statically typed. Screw it. There we go. So, talking about type systems, let's have a disclaimer. This is not a static typing is better than dynamic typing holy war talk. Those arguments have been done to death. I am not bashing any languages. I am saying here's an opportunity we may not have looked at in static typing. Right. So let's have a little story about type systems. We know the correctness story. What I would like to tell you is that there are other things types do, as well as checking correctness. They allow us to talk about code in very, very nice ways. They allow us to talk about code and what it does succinctly and expressively, and because of the machine that's checking them accurately. I'm going to go into this a bit, but one of the things a type system does, from a certain point of view, is give you documentation, and the kind of documentation it gives you is guaranteed to be up to date and accurate. And I know of no other system in the whole of software engineering that can make that guarantee. So, we are going to look at some ways that types can help you communicate with the rest of your team. They're not just about talking to the compiler. They're about talking to other developers. Also talking to other developers now, but also in the future. Where types are documentation, they are correct documentation that will survive you leaving the company. They are correct documentation that will greet you as you join another company. There is so much to get from that code when you've got accurate documentation that's cheap to maintain. And I'm going to go into this a bit, another thing it can do is be documentation that's so succinct and expressive that it helps you analyze your code and look for better ways to write code in a way that a picture, a UML diagram, a Gantt chart ain't going to give you. So, what kind of things can we communicate with type systems? I think there are 3 big fundamental ones, and that's the core of this talk. The first thing you can do with a type system is describe stuff. In software, how do we describe data? How do we do it? Let me give you some wrong answers. We don't do it like this. For a while, consultants were telling us that this would be the way we describe data forever. This is XML, but it's SOAP, a special flavor of XML that's particularly hard to swallow. Right. This does describe data very accurately. The reason I think it failed is it's actively hostile to humans. This may be UTF-8, but you ain't meant to write it and you ain't meant to read it. This might as well be binary. Right. SOAP failed. Despite being good at describing data, it failed because it didn't communicate to humans. What did we do instead? The thing that succeeded was this: JSON as a way of describing data. Like it, love it, hate it, whatever. This is the de facto way we describe data across the internet. This is our de facto way of communicating to the rest of the world's computers. The problem with it is, it doesn't describe data. Not in the way I'm trying to talk about it. What it does is specify a value, right? But look at this value. This is, okay, I can see this is an order ID for 315, let's say, krona, right? There's a lot this doesn't tell me, like payment method is Visa. So is a valid value there also MasterCard? American Express? Cash? Dave promised he owed me? We have no idea. And I can send you 1 million of these JSON packets and you still won't know. Because it describes a specific value. It doesn't describe the shape of data. Let me give you one more thing that isn't good at describing data, and this may be the most dangerous, controversial thing I'm going to say. Java, at least it didn't used to be. It's getting better. But a while back, Java was also actively hostile to describing data. You weren't supposed to describe data. Data didn't really exist without methods. If you tried to define just data in Java, you were a bad Java programmer, and you would be sent off to the gulags for object orientation. Things have got better with records, but I don't think they would have got better. I don't think we would have got records without some inspiration from other languages. So let me tell you what I think is the best way we currently have today of describing data. And if you've programmed in Swift or you like Rust, these ideas may have begun to percolate. You may have heard this wonderful term, algebraic data types. I'm going to try and explain to you what they are and why I think they're great, and maybe along the way I'll tell you why they're called algebraic, which is clearly not a word that came from the marketing department, right? ThoughtWorks didn't call them algebraic data types. That's come from the academics. Right, so there are 2 and a bit parts to algebraic data types. Dead simple. The first one is an idea you've already seen in just about every programming language with a type system ever. It's called a product type, right? And it's easy. It's a struct. It's a record. It's the thing that says an order is this and this and this. You merge together several data types to get a new one, right? And it's an AND. Product type is an AND. Why is it called a product type? Because the number of possible values for an order is all the possible values for order ID, all the possible values for string, multiplied by all the possible values for int, multiplied by all the possible values for payment method. This is a really large type when you think about it that way. But the main thing you need to think about, this is a way of ANDing data types together. If I emphasize the fact that it's an AND, some of you are going to think, where's the OR? Of course you are. Right, there is an OR. And a slightly smaller subset of languages have an OR, and it's called an enum, right? We call this an enum in most languages. You can say clothing size is small or medium or large or extra large or go away to a specialist shop, right? The one you'll always see in textbooks is clubs, hearts, spades, diamonds. That's my first enum. 2 very familiar concepts. The big deal with algebraic data types, and where some languages really missed an opportunity, I think, is the free combination of the 2 ideas. You can mix and match. You can nest ands and ors to your heart's content. If you saw Diana Mortellion's talk yesterday, this is the and. This is the and of the ands and ors, right? When you mix these things together freely, you get so much power. So this is a data type order response. A purchase can be successful and we'll get a new order, or the payment failed and we get a payment provider identifier and some failure message, or there was a network error and I got a status code, probably 404 or 500, and a message, right? That is 10 lines of code. I think that tells me an awful lot about this business and their domain, what they're doing, what they think can go wrong, which error cases they think are important, right? Sure, they're hoping that purchases will be successful, but they're planning for when the payment provider has problems and for when the network goes down, and those are 2 very different classes of error. When I look at this data type, I feel like I'm looking into a hologram of a large part of the system. I've made this example up. I think it's relatable, but I've made it up. Let me give you an actual real-world example of some code I wrote with this. So this algebraic data type, it has heat map items can get loaded, and you get an array of heat map items. The map camera can move around, and that will tell you the new latitude and longitude. You can toggle whether or not you're showing the heat maps, and then there are some payment things, right? So you can begin a payment, you can complete a payment and get a Stripe token. You can get an error from Stripe, you can record a payment. This is actual code, and if you looked at this long enough, you could probably guess that this, and it actually is, we're in the business of selling valuable heat map information to companies, and it was actually the price of property and commercial property around different systems. I can see that all in about 10 lines of code. I can make predictions about what tools we'll need. We were using Google Maps, that shouldn't surprise you. I can make predictions about what's going to go wrong. I can tell you that we only supported one payment provider because we were a startup, and one payment would have been a huge transformational success. So we didn't bother putting in two yet. Right. Just by looking at about 10 lines of code, you can begin to see what the business is about. I don't know of any other system that's that succinct and expressive and tells me things about the failure cases of the software as well as the business ideas. Maybe if I look at database schema tables, that will tell me some of the business ideas. It rarely tells me about the failure cases. This tells me everything. The first thing I do when going to a new company using these types of languages is I just look at the data types, because I can read so much about what they're thinking and what they're planning. So, the next thing, that's describing data, and I think that's a foundational piece. The next thing we try and do above describing data is describe the relationships between different kinds of data. And this is me deliberately not saying the word functions, right? Function. It's the relationship between the thing you've got and the thing you'd like to get. That's what a function is. Or it's a contract. If I give you one of these, will you give me an order ID back? Right? In order to describe this, I'm going to sneak in some Haskell. I'm going to teach you some Haskell notation because I think it's the best notation for communicating these ideas. So, slight segue. Here's some JavaScript code. You can withdraw if you give me a user ID and an amount. Right? I've started with JavaScript because just about everyone will admit they can just about read it. You know, it's a universal language, whether you like it or not. Let's add in some types. I'm going to switch over to Java, and I get public string withdraw, string user ID, int amount, and then the body, right? In Haskell land, how do we change that? The first thing we do is we just look at the types. So public, throw that concept away. User ID and amount, those are names, that's an implementation detail. They're somewhere else. They're probably on the line immediately below, but we're talking about the types. Next small transformation we make is the return type is at the start. We put it at the end. This, to me, if I have one hill I will die on, one thing I'm absolutely certain is correct, it's that the thing it returns should be at the end, right? Because that's how we read time, right? I give you those things and you get the thing. If I had a time machine, I would go back to when C was being written and I would queue up with all the other time travelers who want to talk about null pointer exceptions. And when it's my turn, I'll say, yeah, null pointer exception. Can we also put the thing at the end? That would be good. Okay, we're almost at Haskell. The rest is just syntactic sugar. We look at the types and we do that. A withdrawal is something that takes a string and an integer, and at the end will return a string. The thing at the end is the thing you get back. This is code. It's writable code. It's also, am I going to use the E word? I am. It's an equation. It's an equation that describes a fundamental relationship. It's succinct notation that says, hey, here's some stuff I need to provide you one of those. If you can give me this and this, I can give you that. It's a very succinct way of describing a process. I don't know any other process documentation methodology that is this concise that programmers will actually write. So let's dive into describing relationships. I'm going to give you some examples to bounce around languages. It's the same syntax. I'm going to give these in Elm because this is where I have some nice, approachable real-world examples that have actually come up in real code. So, some Elm type signatures. I was working on, it's a functional front-end programming language. I was working on a website. We had this little small, nice, self-contained thing I can talk about that went wrong. I wanted to generate some icons right on the page, and we use this glyph icons thing. And the thing about glyph icons is you create a span or a div with a CSS class of glyph icon and glyph icon hyphen name of the icon you want. It magically turns it into that, which is my theme for a Friday afternoon talk. Right. So I wrote this code. Easy. How do you get an icon class? Give me a name, I'll give you those two strings. It's just a little helper function. All right. Let me show you the type signature for that, because I can actually ask the compiler to give me the type signature. It will give me back string to string. Give me a string that's the name. I'll give you back a string that's the CSS classes you want. Right? That seems like a reasonable relationship to describing code. Certainly a very common relationship to describing code. It's the world's worst type signature. It's the world's vaguest type signature. This is a ridiculous type signature. Here's the thing you can go away with. If you ever see this type signature ever again in your career, it's probably either a string library or it's wrong. Right? Because what? String to string. Which function is that? What is foo in this? It's icon class. I've just told you it's icon class. But it's also to upper and to lower. It's reverse and it's abbreviate. Give me a string and I'll give you a string back. That is the type signature of ChatGPT. Right? I mean, it is. It is. Actually, if you give me a string, there was a guy in the 1940s or 50s who proved that if you give me a string, then he can do any computable function. The type signature string to string is all of computing. So it's so desperately vague. And if I'd been smarter back when I wrote that code, I would have looked at string to string and realized something is fishy here. There's so much that can go wrong. Potentially, I could give this the name of an icon and I could get back any computable function, at least as far as the type signature is concerned. Let me tell you two things that actually went wrong with this code. The first is someone mistyped user and nothing displays. Of course they did. Of course they did. Of course that happened, right? The other is, so wrong input. The other is string to string. The problem with string to string is you can call it on itself. And we got this situation where someone accidentally called icon class on icon class and got this whole thing. And I don't know which glyph icon it tried to show, whether it tried to show user or the glyph icon project's glyph icon, or if it just exploded. But it was broken. And I should have seen it from the type signature. And if I can teach you how to read type signatures, you can spot these errors before you even try to run them. So how can we fix this? It's a vague type signature. We can fix it by being more specific, right? So we can replace this one with something specific. Give me an icon, and I'll give you back some HTML. That's what I was really driving at. If I can communicate that to the compiler, the rest should be just a simple matter of programming. So I did that. I took that type signature, I implemented it, and I ended up with something that was reliable, right? The whole universe of inputs is user, heart, and glass. Very small universe of inputs, very small potential footprint for things I can control here. It's easy to read, it's easy to write. If I want to extend it, that's going to be trivial, but for now I can see the whole world in one line of code. And the output is guaranteed to be something that can't be called in itself, that is sensible to send out to the web. Right. So the type signature not only reveals the structure of code, which is a good thing in itself, but it can also flag up problems. And when you see the problem is, I've tried to express an idea and I didn't express it clearly, it suggests how we can structure a solution by being more clear. Right? Clarifies what we're trying to do and what we're not trying to do by excluding the whole universe and narrowing down on the problem. Let me give you another example. This is also real world code. It's quite similar, but it's going to let me introduce a couple more ideas. So this is from the same code base. You will be familiar with this idea. You've got a website, there's a URI, and we're going to try and turn that user-entered URI into the name of the page we want to show. So if you go to /account, you get the dashboard, and if you go to /account settings, you get the settings page. / takes you to the front page, anything else should 404. Look at the type signature for this one, and fear. It's string to string again. So there's definitely something wrong. This is too vast. But the input string, that's actually correct. That's something the user can enter, right? So it has to be any possible string they can enter. I can't change that one. I can change something about the return type. So I'm going to set up a view which is a finite universe of things this can return. I look at this type signature now and say, okay, so there's an infinite number of possible inputs, but a small, finite, understandable number of outputs. That sounds like dealing with users, right? It does. It sounds like, okay, they could tell me almost anything. I'm going to try and narrow that down to something specific. We rewrote the code to look like this, right? Pattern matching. Another great idea. So that's great. Taking a type signature, narrowed it down, taking a bad type signature, it's communicated badness to me. Got a better type signature, and I can use that to drive better code and explain the code to my colleagues. I also get a new colleague from this, if the language is doing it right. I get a new colleague, which is the compiler. And I don't want to get too much into correctness, but when you can communicate to a computer in a way that communicates with your colleagues and the computer, your computer can almost become a colleague. So I wrote this code. This was actually something I wrote along the way. And my colleague, the compiler, looks at this and says, well, over here, you said that there are 4 different kinds of view. But over here, you've said there are only 3 different kinds of view to worry about. And the compiler say, well, you've made 2 assumptions. Which one's right? Is there a discrepancy there? And it tells me very helpfully, this is why I picked Elm for these examples. It has beautiful error messages. It tells me I'm missing a case, right? It's read my documentation too and understood something about it. So I get compiler help as a bonus. And I want to throw in this idea. The nice things about having a compiler as a colleague is they're not as smart as your other colleagues, but they're more thorough. Right? It's great. A computer will tirelessly go and check all the code for all the assumptions you've ever made, provided you give it the information to work with. Okay, for time, I'm going to jump to the next big idea. So, describing stuff, describing relationships. These ideas are percolating or have percolated into mainstream languages. There's one more big idea that I don't think we've got on top of yet, that I hope soon will percolate into the mainstream. And it's the idea that stuff and relationships happen in a context. We execute code in an execution context. So, let me show you 3 functions. Here is show greeting, takes a user, gives you back a string. Fetch user, give me a user ID, I'll give you back a user. Create invoice, order ID, user ID, give you back a PDF. These are all happening in a context, right? And I'm going to get into this, but let me show you the notation for it first. Languages like Haskell and Elm and Friends let you not only to say what the relationship is between specific types of data, but the context in which they happen. So I can write this code in Haskell. I can say a withdrawal is something that needs a user ID and an amount, and will provide you with a withdrawal ID, provided you give it the execution context of being able to access a database. Right? Because it doesn't happen in a vacuum. You can almost see that if I give you a user ID and an amount, in order to create a withdrawal ID, there's going to be some kind of database-ish thing to happen, or maybe some kind of web-ish thing. but this makes it explicit. So let me go back to my examples and talk about explicit versions of the context in which they're running. Show greeting takes a user, returns a string. Probably should just be that simple. It's going to say, hello Dave. Right? It's a very simple function. Fetch user takes a user ID, gives you back a user in the context of accessing the web. Right? And won't run unless you can give it the context of accessing the web. Create invoice. Similarly, takes a user ID and an order ID, and it will create you a PDF provided it can access the database. If we build the context into this description of our software, we can reveal some dependencies, like depends on the web, depends on the database. Because the computer is checking that these things are accurate, and that's as far as I want to go into correctness, but it's a documentation that you can trust. Insofar as it does that, not only does it reveal what your software depends on, but what it doesn't depend on, right? Creating an invoice doesn't need HTTP access. So if I'm worried about sending user data over the internet, I have one function of those three where I should actually worry about it, because the other two are guaranteed not to operate in that kind of context. If the compiler checks it's true, we can learn something we can depend on. But also, as long as this documentation, these type signatures are accurate, we can start to look at them and analyze them as though someone had handed us a document that was up to date and true and guaranteed to be so. So let's have a look at the create invoice one. I think that's an interesting one. So you probably have an intuition about how this software is going to work because you're all experienced software people. Create invoice, takes an order ID and a user ID, goes to the database and generates a PDF. I can sort of see how that code is going to work just from that description, which is a good thing. I see a problem with this. What is it about creating an invoice that needs full access to a database? I'm not sure it does. With the right tools, with the right language, I can make this a better type signature. I can say, actually, this code just needs the context of being able to read the database. If I've got a language that lets me express that idea, I can put that into the code and know it's true for all time. And I can learn things like somebody says, oh, the database is getting overloaded. I want to spin out a read-only database. Do you know any code that's going to work on the read-only database? Yes, I do. Are you sure? Even more sure than if I checked it myself, because I'm a fallible human. The computer's checked it for me and said, this is code that only needs read access. This is obviously also a security improvement. This isn't going to accidentally delete the database because the computer's checked that it can't. And I know that just from reading the documentation, which is accurate and up to date, guaranteed. By looking at a type signature and saying, hang on, is that the right type signature for this code? You can start to tame the complexity of a system. You can reduce its footprint, narrow its scope, make a smaller context that's more appropriate. But you can also do something else. By looking at this same type signature, I think we can do something which we've been told to do for years, but we've never been told how, I think. Maybe there's some people at this conference who will tell me I've been telling you for 20 years how to do this, but hey. It lets you decouple some context. Look at this code, right? Create invoice, takes an order ID and a user ID, reads the database, and generates a PDF. That kind of bugs me. That's a very complex relationship. It takes two identifiers, magic on the database, and returns a PDF. That seems like it's abbreviating several steps. I would like to rewrite this code. It makes me uneasy. I'm going to refactor this code into two much simpler functions. Fetch invoice, order ID, user ID, reads from the database and gets you an invoice, which I check the other file and I know an invoice is just an AND of order and user, right? And then I have a separate function that takes an invoice, generates a PDF. Same task accomplished, but I look at this and say, okay, I think I know how fetch invoice is implemented. I think it's going to do select star from user where user ID equals, select star from order where order ID equals, and just return that mush together. Testing databases is hard and miserable for so many reasons, but this might not actually need that much testing because it's pretty simple. It's to select stars where, right? I find that code hard to test, but I also find it doesn't need that much testing. Meanwhile, create invoice, that seems like a much more complicated piece of code, particularly because not only do the software developers have an opinion on it, but marketing and finance have an opinion on it, and the graphic designers have an opinion. Everyone's got an opinion on. Everyone in the company has an opinion on this second type signature. It's going to be really complicated to get right, and it's going to change every time we change our logo a bit or the layout. But it's easy to test because it has no external context dependencies. It's a pure function, if you'll let me use that term. It's just the transformation of one kind of data into another. I look at these two functions and I say, hard to test, easy to get right. Hard to get right, but easy to test. I feel a lot better about these two functions than the one at the top. And I get that just by looking at the first function and saying, that looks like it's doing a lot of work. Right? Type signatures are the only tool I've ever found that communicate to me where I need decoupling and how I might do it. And I've been told for decades that decoupling is great, but not how to do it on my code base and where to find opportunities for it. Yes, I've already said that. So, how are we doing for time? We're coming up a little fast, so we're going to have time for questions. Good. Right. So, let me sum up those three big parts. A good type system will do three things for you. A good modern type system of the kind that's gradually percolating, and I'm trying to make it percolate more. It will let you describe things. It will let you describe the relationships between things and the context in which they happen to your computer and to your colleagues. And from a certain point of view, that is the whole of programming. Right? Or it's the whole of communicating about programming. There are stakeholder discussions that people from ThoughtWorks didn't tell you about, and that's not my domain. My domain is computers. But a good type system should be able to do this because this is the whole of the story we need to be able to tell when we're in the programming mode. So, great, Kris. These seem like interesting ideas. I want to explore them more. Where do I go next? This is my chance to do some end-of-talk propaganda. Here are 4 languages I would commend to you that explore these ideas. There's Haskell, Elm, PureScript, and Unison. Haskell is the one you go to if you want loads and loads of books about it. It's the OG for a lot of these ideas. It's also the one you want if you want to take these ideas and see how far they can possibly go in computer science, which may be a goal. Elm is the one you pick if you like the sound of these ideas and you want the easiest possible learning journey to getting the big parts of the ideas in your head. Elm is the most programmer-friendly language I have ever encountered. Its creator put a lot of effort into that and it paid off. So if you want to learn functional programming, all these ideas, start there. PureScript I mentioned because that's probably my go-to language these days. It's Haskell with some of the cruft shaved off, and it runs on the back end and in the browser, so I can do lots of fun things with it. And the last one is Unison, which takes these ideas, and it's the one you go to if you want all these ideas, plus some really interesting ideas about how we collaborate on software. But you can also get them just by looking at the languages you're probably already using. These ideas, as I kept saying, are coming up in languages like TypeScript, Rust, Swift. You can find them in Gleam, which is a very nice programming language. If some of these ideas are already familiar to you and you want to go even further, let me recommend 2 books. There is Type-Driven Development with Idris, which introduces a 4th concept of can we describe how things are used up over time. I've chosen not to go into that one, right? But Idris is an exploration playground for is there more we can do with type signatures when we think about a changing system over time? And there's the book Thinking with Types. If you're asking yourself the question, what okay, I can express a lot of things with these ideas. How far can I push that? How much information can I shove into the type system? You would be amazed. You will probably need to lie down afterwards. Next bit of propaganda, and coming to the end, I'll just quickly say, if you would like to hear more from me, if you're not already sick of the sound of my voice, if you'd like to hear more, I'm going to pitch my podcast at you. It's called Developer Voices. This week's episode is on building full-stack web applications with Lustre and Gleam, which gives you the best of functional front-end programming and typed actors on the Erlang beam in one. That's this week's episode. It's cool. With Hayley Thompson, who's wonderful. Enough propaganda. Thank you very much.